This is Sara.
Hi, Sara.
Sara is a plant scientist at the University of Oxford. Sara has a random bag of rocks, but she doesn't know what any of them are. So let's see what's in Sara's random bag of rocks. Yeah.
Hi, Sara.
Hi.
What have you got for us this time?
I'm super excited. I think this is like my favorite one because it's like super wavy. Yes, like what's going on here? Like, why is it wavy?
Let's find out with science. Yeah, it's got lots of layers in it. When you've got fine layers like that, we say it's laminated, alternating dark and light bands.
Just like a wavy zebra.
It's like a wavy zebra. And we've got conchoidal fracture again, which means that we've got homogeneous material in there. But it might not be chert again. And if you feel the sides there, they're not smooth flat. You can feel they're bumpy, they're grooves. These lighter bands stick out slightly more.
So they're more resistant to...
So the light bands are more resistant than the dark bands. These vertical lines there, that's usually when you've got carbonate growing under pressure.
So is it perpendicular to the band?
There. See how those vertical lines?
Okay.
Yeah, and it's very wavy, but that's not. But the beds maintain their thickness. So if the beds change thickness, then you'd assume that was sedimentary, like sediments draping across topography. But these ones maintain their thickness all the way through. So this is tectonic. This was turned to stone and then it was folded. And you can actually see that some of the thinner beds are shearing against each other. They're sliding across each other. So if you imagine like when you have a thick book, like a phone book or something, and then you bend it and the pages slide over each other.
Oh, like a Yellow Pages or Argos catalog kind of thing.
Yeah. That's called flexural slip. And in some of them, that's making like little crenulations, they're called.
Is that like kinks?
Yeah, little kinks.
Cool.
Yeah. So let's see if it's porous. No, I didn't think it would be. It's obviously being compacted quite a bit. So the light layers are very smooth, very fine-grained. They have a cementy smell, and that would make sense that they've got carbonate, which means they've got carbonate in, and that makes sense because those vertical lines we call cone-in-cone structures, and that's when you get a carbonate that's been put under a huge amount of pressure. Well, not a huge amount, but a lot of pressure. So the light bands are harder than my key, so that's probably got quartz in it. And the dark bands are also harder than my key, so they've obviously got lots of quartz in them as well.
But then you were saying one is like more resistant than the other?
Yeah. The darker bands will probably have more clay in them because they've got much finer laminations in the darker bands. And that clay, sometimes when it gets pressurized, it releases silica when it starts to change into other forms during metamorphosis.
So this went under quite a lot of pressure?
Oh yeah. So it was a sedimentary rock, and it started to get metamorphosed. Oh, you can smell there's like organic matter and sulfur in those dark bands, so it's probably full of organic matter. So it was probably like a mudstone on the seabed, and then it's undergone burial, deep burial, and it started to get tectonized. So you call it a metasediment. It's still a sediment, but it's like on the verge of becoming a metamorphic rock. So for this to happen, you need to have and because it's laminated and you can't see any sedimentary structures, it's deposited somewhere below wave base. So you need like a fairly deep water to deposit in, and then some kind of tectonic regime like continental collision to start burying it to depths where it could get squished, and then we can see it's being squished this way as well. So it's probably
squished in different directions.
So squished vertically and then squished horizontally. And because it has been metamorphosed much, you can see it was probably on the edge of the continental collision. So like at the edge of the base, of rock base, it's called. Cool beans. Excellent. Oh, that one's really exciting. It's really nice. It's going to polish up nicely, this.
Cool.
Thanks for bringing it in. That one was really exciting.
Thank you.
Bye.
Nice big wave.
Bye.